We know what is a onto function. So if you have elements here, every element here should have a image, or every element here should have a pre-image, which is correct. Yes? When do you say a mapping is onto? Forgot. Every element there, here, codomain. Very good. Every element in the codomain, that should have a pre-image. Do not have any element hanging in the air here. Extra elements here are allowed. Okay? On to mapping, right? Okay. Now, let's take this as one set, this is another set. And I have a mapping. Say F. F is a mapping between these two sets. Then I have another two sets. Let me call this set as X, this set as Y. Okay? 1 minute. So, let me pick up another set Z. Now, what I do is, there is a function that connects two sets, X and Y. There is another function, I'm going to have another function that connects Y and Z. Let me call that as G. Okay, a function G. So I have two functions, F and G. I have three sets. Now my aim is to have a composition of functions. Composition is, I'm going to combine these two. What will happen? And that composition of functions is represented using the notation F circle G or G circle F. F circle G means this side to this side. G circle F would be G first, then, right? So that's the notation that it has. Now let's formally define what it is. Okay? Till this clear to everyone? Can you see the board clearly? Those attending online are able to see the board?
Yes, ma'am.
Okay. This is okay? Now, I'm going to define this. Get circle. Now, if there is a function f, I post the notes so you need not worry about it. The entire notes I have as a document, I'll send it first unit, okay? If f is a function between the sets x and y, g is a function between the sets y and z, then I find the composition of function f circle g defined as g of f of x. G of f of x. Of g of x, okay? F circle g is g of f of x. And that would be from x to z. Okay? X to z. It's combining both, no? So f circle g is a function from x to z. Do I make sense? Understood? Let's have an example, then you will understand better. So have this diagram in mind. X to y, y to z. I'm combining both. It goes from x to z. That's the idea. Now, let's take a simple example. Now, these types of problems generally asked in 2 marks. Huh? They'll give you some f, they'll give you some y, sorry, f and g, and then ask you to find the composition. Very simple. So suppose I'm defining my f of x is equal to x squared, and my g of x is equal to, say, x plus 4. Okay, something like this. Now I have defined f of x is equal to x squared g of x. I want you to find f circle g of x. F circle g of x means what? According to the definition, it is g of f of x. Isn't it? G of f of x. So it is g of f of x is what? X squared. G of x is what? This one. So what happens? G of x squared. Instead of x, you should put x squared. So what will the answer be? X squared plus 4. Correct? Got the point? Understood? So g of x means it is of the form x plus 4. X in x x squared x squared x squared Understood? Yeah. So now what is my composition F circle G? That is x squared plus 4. Understood? Okay, let us do another simple example. Maybe we define M. Yes, come in. Yes, good morning. This is GC mathematics. Yeah. Okay, so let's have this as one example. Now, what did we define our F circle G as? F circle G is G of F of X. Okay, that's the definition. So have that in mind. I'm doing composition of functions. Okay, so suppose I define F of X as X plus 2 and G of X as X squared. And I want to find F circle G. F circle G means what? G of F of X. Then write G of, write the values F of X. X plus 2. Okay? G of X, this variable means variable squared is a function. So here instead of this variable, I have this whole thing. So what should I write here? G of X plus 2 is? புரியுதா நான் சொல்றது? G of X இருந்துச்சுன்னா, X இருந்துச்சுன்னா அது ஸ்கொயர் ஆயிடும் ஃபங்க்ஷன்ல. G of X plus 2 சொல்லுப்பா. Very good. X plus 2 whole square. இது ஒரு வேரியபிளா வச்சுக்கோங்க. Y னா y square. Correct? Understood? So this is another example. If your F of X is G of X is given, finding out the composition of functions. This will be answered in 2 marks. Okay? Right. So if you want, you can simplify this. A plus B whole square, no? A squared plus B squared plus 2AB. Otherwise, you can just leave it as it is. No problem. Clear? Did everyone understand this composition of functions? Yes? Now, same problem. Let's do G circle F. Same problem. G circle F. G circle F means it is F of G of X. Okay. This is F of. So write your G of X first. F of X means it is X plus 2. So X is பதிலா நமக்கு என்ன இருக்கு? X squared இருக்கு. So what should I write here? X squared plus 2. Is this right? Or X plus 2 whole squared? What should I write? X squared plus 2. You are convinced with that. What about the others? X squared plus 2 or X plus 2 whole square? X plus 2 whole square? Sure? Convinced? Why? Because if this is your y plus 2 form மாதிரி இருக்கா? Variable மாத்திரம் மாத்திரம் full function மாத்தி இருக்காது. Okay? You understand what I'm saying? Those attending online, are you able to understand what I'm saying?
Yes, ma'am.
Okay. So now I have G circle F is X squared plus 2. And my F circle G is X plus 2 whole square. Are they two equal? No. So the conclusion is F circle G not equal to. In some cases, very rare cases, depending upon the function, you might get it as equal. But generally, it is not equal. Is that okay? Understood? So that's all about the composition of functions. So this was one topic that I left unattended. And the last topic that I skipped was Cartesian product of matrices, of sets. So when we were talking about sets, suppose I have a set like this and another set like this. Then you studied in your lower classes about the Cartesian product of sets. Cartesian product of sets, and that notation is A cross B. Don't read it as A into B or A multiplication. Multiplication means if you find the matrices of two things, we just don't write A matrices. We just write AB. That implies it's matrices. Okay. So for sets of here, we don't put just A into B. We use A cross B. With A cross B, then it is Cartesian product. Cartesian product means what? Now this will be the collection of all elements, okay, in this form. Ordered pair. You heard the word ordered pair? Yes, one pair of elements. So you collect all the elements. So all the elements of this Cartesian product will be ordered pairs, where A will belong to this set A, and this B will belong to this set B. You should not change the order. That's why it said ordered pair. When you write the definition also, you should write this. It's a collection of all ordered pairs. The first element should belong to this first set. The second element should belong to the second set. You should not change the order. Is that okay, children? Understood? Now, give me from this, what is A cross B? What will be A cross B? It will be the collection of all some ordered pairs, isn't it? So, what are all those? What's your name? Sibi Chandra. Tell me. Okay. 1, which 2? This 2 you want to take, correct? Yeah. Please listen there. 1, 2. You write it in round brackets, ordered pair. Then I take this 1 with other elements. That's easier. I won't miss out anything. 1, 8, and then 1, 9, then 2, 2, okay, 2, 8, 2, 9, 3, 2, okay, 3, 8, 3, 9. All the ordered pairs I have written. Now, if you check, it is a collection of all ordered pairs of elements, where the first element in the ordered pair belongs to this set, second element belongs to this set. This is how we define the Cartesian product of two sets. Clear? Any doubts for anyone? Okay. So with this, actually, we complete the entire sets, then the functions, and in matrices, we have done, we have defined addition of matrices, that is operation. Addition of matrices, subtraction of matrices, product of matrices, correct? Then we have, for a matrix, we have defined what is a cofactor, what is a minor, okay? The only left out thing is what? Adjoint and then inverse. Very good. So if we define adjoint, we can define inverse. With that, the matrix would be over. All right. Now, if I give a simple example of a matrix A, will everyone be able to write the cofactor of it, the minor of it, and then the cofactor? You all know how to write the transpose of the matrix also. Based on all of those, we'll write the adjoint. And then write a formula. What is A inverse formula? By any chance, you remember what we did? A is a matrix A inverses. 1 by determinant of A into, very good, 1 by determinant of A into adjoint of A. So we know how to find the determinant. That also we have done in one of the classes, right? So everything we know. When a matrix is given, you know how to find the cofactors, the minors, and everything, correct? After you find the cofactors, you can write the adjoint. You know how to find the determinant. Then just put it in the formula, 1 by determinant of A into adjoint of A, that will give you the inverse. So that is what we are going to do in today's class. Okay, those attending online can take a paper and a pen and then sit down and do, because you are only going to do now. Get your paper and pens ready. I'll give you a matrix. Ready? Shall we go on? They must be sleeping, no? Like you were sleeping yesterday. Taking turns and sleeping today. Huh? Poor thing, the teacher alone has to shout every day. What do you say? No? Huh? You all don't listen, no? You sleep and eat and listen. உண்மையா சொல்லுங்களேன் அப்படிதானே? ஆ ஆமா தானே? இல்லையா? ரொம்ப நல்ல பிள்ளைங்களா இருக்கீங்களே. Okay. So I'll give you a matrix. Huh? Determinant you know to find for 3 by 3 matrix also? Yes, sure. Shall I give you a 3 by 3 matrix? Just a random, okay? It might be some bad negative. Just try. So first write the cofactors. Okay? How do you write the cofactors? Cofactor of 7. Huh? A11. That is 7. Cofactor of 7 I'm writing. How do you write that? So leave this row and this column. That what that element is N. Okay? And then take the other one. Make 0, 3, 6. For those of you who did not attend the earlier class. Determinant of 803. Correct. Determinant value means this diagonal minus this diagonal. So this diagonal is this one. 8 into 6, 48. Then this diagonal minus 0. So this is 48. So the cofactor of 7 is 48. Understood how I'm finding? Same way you find for this one. If you want to find for 2, what should you do? Leave this row 2 and this one. So this will go off. You have to write 1046. Like that, find out the cofactors for all of these 9 elements. Please answer your attendance. Ashika, Surya, Gayatri.
Present, ma'am.
Okay. Anastasia, Arunika.
Present, ma'am.
Okay. Mohammed, Aswathaman, Naveen, Varshini, Kishore.
Present, ma'am. Varshini present, ma'am.
Okay. John Matthew,